Hi, I'm Mike Bloom. I'm an AI solution architect here at Weka. We're here to talk about the infrastructure behind generative AI. Let's talk about vector databases. Vector databases are specialized databases designed to store, manage, and query high-dimensional vectors, which are numerical representations of data points in a vector space. These vectors often represent complex data types like text, images, or other unstructured data after being processed by machine learning models such as embeddings for deep learning models. Vector databases are critical to the functioning of Retrieval-Augmented Generation, RAG, pipelines, which is leveraging vector search capabilities to enhance the accuracy and relevance of the outputs generated by large language models. In these pipelines, vector databases manage the storage and retrieval of embeddings, dense vector representations of textual data, enabling efficient and precise information retrieval. Embeddings in a RAG pipeline are constantly evolving, reflecting the relevance of their underlying data. Cohere, for example, employs lineage to track the origins and updates of embeddings, allowing the system to decide which embeddings to rank higher or derank as source documents become outdated. This dynamic management ensures that LLMs generate responses based on the most current and relevant data, preventing the retrieval of outdated information that could degrade the quality of the generated outputs. So that's a generalization of vector databases. Let's talk a little bit about specific types of vector databases and their unique values. Milvus is designed for large-scale similarity and nearest neighbor searches, offering high performance and scalability. It's an ideal choice for applications requiring the efficient handling of massive embedding datasets. Pinecone is a managed service that provides real-time vector search with low latency. Its managed infrastructure simplifies deployment and scaling, making it popular among production-ready RAG pipelines. Weaviate is an open-source vector database that integrates vector search with semantic search and knowledge graphs. This combination is especially powerful for RAG pipelines requiring deep contextual understanding. ChromeDB is a lightweight and flexible vector database optimized for high throughput and low latency operations. However, it uses SQLite as a backend, which can lead to limitations in write performance, impacting the speed of ingestion and deranking embeddings. Elasticsearch was originally a text search engine, and it now supports vector search, making it a versatile option for hybrid search solutions. It's scalable and integrates well into traditional search operations. PostgreSQL can be extended with pgvector extensions to support vector search. And while it benefits from combining relational and vector search in a single system, it may face challenges with write performance, particularly when scaling for large data sets. MongoDB's Atlas search supports vector embeddings, enabling vector similarity searches within a MongoDB ecosystem. This is advantageous for applications already leveraging MongoDB, although write performance may require careful design and consideration. Vespa is a high-performance, scalable vector database designed for large-scale applications. It excels in real-time data processing and retrieval, making it suitable for use cases that demand immediate response times. Vald is a Kubernetes native vector database focused on the ease of scaling and deployments in cloud-native environments. It offers good read and write performance, making it well-suited for cloud-based RAG pipelines. Qdrant is an open-source vector database optimized for performance, particularly in cloud environments. It offers high write throughput and real-time query capabilities, making it a strong choice for applications requiring frequent updates to embeddings. To rate each of them, Milvus is excellent for read and write performance. Pinecone has excellent read performance and good write performance. However, it is a hosted service, so you have to pay attention to how close it is to the LLM or you'll incur latency. Weaviate's very good at read and write performance. ChromeDB is very good at read performance, and it's moderate to low write performance because of the SQLite backend I mentioned earlier. Elasticsearch has excellent read performance and moderate write performance, especially if it's properly configured. PostgreSQL with pgvector is great read performance and moderate write performance. MongoDB has great read performance and moderate write performance. Vespa's excellent read performance and excellent write performance. Vald has good read and write performance. quadrant, really good read and write performance. Hosted vector databases such as Pinecone offer the advantage of managed services, reducing operational overhead. However, they often introduce higher latency due to network communication over TCP between the application and the hosted service. This latency can impact the time to retrieve embeddings, which directly affects the time to first token and the overall latency of an LLM-generated response. Local vector databases such as Milvus or a locally deployed PostgreSQL with pgvector offer lower latency due to data locality. They're just really close. This setup is particularly advantageous for applications requiring minimal latency such as real-time or on-premise deployments. However, local deployments can become more complex to manage and scale. RAG is a powerful strategy to combat hallucinations in large language models, which can occur when models generate plausible but incorrect or irrelevant information. By incorporating retrieval from real-world datasets via vector databases, RAG ensures that LLM outputs are grounded in actual referenceable information. This reduces the likelihood of hallucinations and enhances the trustworthiness of responses, especially when multi-shot citations are provided to back up the generated content with verifiable sources. This approach not only improves accuracy, but it also builds user trust by offering transparent, reliable answers.
Thanks for watching AI Demystified. See you next time.